Hi everybody, this is Mr. Folly, and welcome to podcast 5.3. Sorry it's coming up a little bit late. Right now I'm doing this about 6 o'clock. I had some problems, so hopefully it'll be up by 7 by the latest, so I'll put that up on headline too. We've got some ideal gas calculations, gas stoich, so I always go through moles, rate of diffusion, effusion, which is a bit of review from yesterday, an ideal gas with correction, which is called the van der Waals correction, which we talked a little bit about today from one of the AP problems. So let's go ahead and jump right into it. Ideal gas law is PV equals nRT, or to find molar mass, PV equals mass RT over molar mass. And basically what I did is N equals moles, and moles equals mass divided by molar mass. And that's all I did was I just substituted. Or to find density, since density equals mass over volume, I can basically solve for mass over volume. So PMM over RT will give you density. And of course, M over V equals density. So on a couple of problems that we have, it's actually asking you for M over V or density. So just be aware that these are derivations of everybody's favorite ideal gas law. So let's do the examples. You want to get out your calculators and probably your periodic tables for these two. The mass of 1.12 liters of gas Y is found to be 6.23. The density of gas Y is. By the way, on these questions, we get to assume STP, which of course makes me mad because I ranted and raved about how it's never STP, but for these questions it's going to be. So the mass under certain conditions is 1.12 liters, is found to be 6.23 grams. So density is just love, right, with a knife through it. So my mass is 6.23, and my volume is 1.12. So 6.23 divided by 1.12 is 5.56. And then I just like to check my units. This was grams, this was liters, 5.56 grams per liter. By the way, this is what we're doing in class a little bit tomorrow, so there's 18 for you. The molar mass of gas Y is, again, we are sadly assuming STP, but we are. So molar mass of gas Y, whenever you have molar mass, it's PV equals mass RT over molar mass. We're assuming STP. I'm going to actually make this red, so maybe that'll be a little clearer. So my pressure is 1. The volume was 1.12 liters. The mass was 6.23 grams. And grams is good with the R that we're using. 0.0821 is R. Temperature is 0 Celsius, but of course that's 273 Kelvin. And then solve for molar mass. And of course, don't solve for 1 over molar mass, so get molar mass out of the denominator. So 6.23 times, divided by, times 0.0821 times 273 divided by 1.12 equals 124.7 grams per mole. Oh, man. Oh, 125 right there, see. All right. 20 is found that 250 milliliters of a gas at STP has a mass of 1.52. What is the molar mass? Again, it's just PV equals mass RT over molar mass. So, you know what? I'm going to skip that one because I'm running a little late. I want to get this up as quick as possible. Exact same equation. 21, when 0.72 grams of a liquid is vaporized at 110 and 0.967 atmospheres, the gas occupies a volume of blah, blah, blah. The empirical formula CH2, what is the molecular formula? Okay, so molecular formula is based on the molecular mass. So if you remember, the empirical formula is CH2. So that means that from the periodic table, it weighs 14.03 grams. And I want to know how many 14.03 grams are going to fit into my molecular mass. So I'm going to solve for my molecular mass here. My pressure is 0.967 atmospheres, a good unit for our R. Volume is 0.559 liters, a good unit for R. Our mass is 0.72 grams, the good unit for R. So R is 0.0821. And the temperature is 110. Boo. It's not 110. It's 110 plus 273 because I need it in Kelvin. 383. Where's my variable? Oh, mass over molar mass. Duh. Sorry about that. So solving for molar mass, I get 0.72 times 0.0821 times 383 divided by 0.967 divided by 0.559, and I get a wonderful answer of my molar mass is 41.9 grams per mole. So now I want to know how many 14.03s fit in there. So 41.9 divided by 14.03 equals 2.99, which is 3. So CH2 times 3 equals C3H6. Yay. Sorry I skipped 20. I just want to get this thing up online as quick as possible. So next question. Now we got to do the stoich stuff. KClO3 solid decomposes, forms KCl solid plus O2 gas. An important part about things that they tell you about these things is when you're trying to find for volume for different things, we assume the volume of the solid is negligible. And remember, negligible means it's so small it doesn't matter. It doesn't mean it doesn't exist, it just means it's so small it doesn't matter, just like what Amanda says in class. She wanted to mention, there you go. 3 gram sample of KClO3 is decomposed in the oxygen at 24 degrees and 0.182 is collected. What will the volume of the gas be? So what I'm going to do is I'm going to convert 3 grams into oxygen, but I'm not going to convert it into liters, I'm going to convert it into moles. The reason why I'm going to convert it into moles and not liters is 22.4 liters does not equal a mole. Does not equal a mole. It never, never, never equals a mole unless you're in Disneyland with the band playing Mickey Mouse, yuck, yuck, yuck. So we're going to go into moles, and then we're going to PV equals nRT it to get our volume. Okay. So 3 grams of KClO3. And the molar mass of KClO3 is 39.1 is potassium, plus 35.45 is chlorine, plus 48 is 3 oxygens. So times dividing bar, 122.5 grams KClO3, and 1 mole times, that's KClO3. And then using my coefficients, 2 moles of KClO3 and 3 moles of O2. And that'll give me my moles of O2. So 3 divided by 122.55 times 3 divided by 2 is 0.036 moles. Whoops, it's not writing that very nice. Moles. And then if I want to figure out the volume of gas, PV equals nRT. So my pressure is 0.812 atmospheres, a good R unit. My volume is, my volume is what I'm solving for. My moles would be 0.0367. Which is what I just calculated. R is 0.0821. And temperature is not 24, it's 24 plus 273, which is 297. Sorry. And then solve for volume. So volume is 0.0367 times 0.0821 times 297 divided by 0.812. And I get 1.10 liters. Oh, so if this is in milliliters, that would be 1,100 milliliters, except for I didn't write 1,100. 1,100 milliliters, which would be 1.10 E3, which would be C. Oh, what did you? It's like a whole homework. Nice. Being even better, it would change my. Come on. Here we go. I'm gonna save this one. I think AL. Forgive.